Yes, the recording is now on. So, I want all of you to open the math syllabus books. Yes, this time around I'm not going to expose it. I just believe that people try to look at something about mechanics. Yes, realize they weren't part of term 1 work, depending on the follow-up we did the other time. But at least I know most schools try to do something about mechanics, and most of them began with forces. And the very subtopic under the topic of forces is composition and resolution of forces. You may not know the name of the topic, but you may know what is actually done in the topic. This topic that has resolving, that topic where you bring in trigonometry, sine and cos, blah, blah. You subtract, get the magnitude, you use tan, you get the direction, such funny things. And they were disturbing a lot of people. So I want to first check, as usual. I couldn't put up a poll because it had to be detailed enough, so it could give me hard time. So before I begin officially, who is going to be our pastor for today? Who is going to be our pastor for today? Lynette. Lynette, raise up your hand. Lynette, raise up your hand. I choose you. You be our pastor. Okay, Lynette. First pray, then I make further communication.
Okay, members, let's pray. Father, in the mighty name of our Lord Jesus Christ, we want to thank you for this beautiful day. I want to thank you for the gift of life. Thank you for this session. I want to thank you for our teacher and everyone is attending it. We pray, oh Lord, that whatever that's going to be taught may it be understood, O King of Kings, that we shall apply it, O King of Glory, everywhere. In the mighty name of our Lord Jesus Christ, we have prayed and believed. Amen.
Thank you, Lynette. Thank you, Lynette, for the word of prayer. People have audacity. Now someone is wanted to share their whiteboard. What are you even sharing? Okay. So I've seen some people saying in the chat that they don't have the books. Okay, have decided to share. So as I promised, guess what? We have finally started on term 2 work. Why? Mechanics are supposed to be taught in term 2. So whatever is going to be taught is going to be in introduction format. But at least at the end of it all, we have to answer the item we have. That's our item and it's ready, as you can see the screen. But let's first see what the syllabus actually urges us to handle for mechanics. The very first topics, they're the ones I'm interested in. Yeah. So those who don't have the book, you can just take a screenshot. What is on screen is what we are interested in for now. Share the link to your friends so that they join us. We don't want anyone to miss anything. I think you can see those people who have started writing in my screen. You tell them how we handle things here. So I think it was Lenovo or Levono. Remove those yellow lines you put in screen. Tap on them and delete them. Don't disorganize us. The lesson has just started. So as usual, we first do some voting in the group. Yeah. The first topic is that topic of resolving forces. The one that has the resultant force, a force with a certain angle, maybe 60. Then you see the teacher putting sine 60, again cos 60, such things. Again, they put a negative, a positive. So I want to know in the comment section, in the chat, I want to see those who have done that work at school and those that have not done the work. I want to compare the numbers. That is our first task before I proceed. So I'm in the chat watching. Okay, I've tried to read all your concerns. I think you people, you can see there are those that have covered everything. There are those that have not covered. You see that? That's what I was talking about yesterday. Eh, but we are going to get a solution, don't worry. So that's why we resolved and said, let me first remove these yellow lines in the screen. That's why we resolved and said that at the beginning of May, which is tomorrow, let us start the premium lessons so that we plan well. So those who are going to join us in the premium season that is beginning tomorrow, worry not. We are going to be so organized so that we have a lesson of those who are beginning mechanics from scratch, a group of those who are just going to revise it like that. Add some volume. It's supposed to be your device. For the case of volume, my device is okay. Yes. So let me get you let me get our book here. Let me get our book. Then the other thing I want to pass on here, you people, there are some questions you should be asking from your groups. Someone is like, sir, how do I watch a recording? There are people who actually who are with us in the beginning. We try to teach you each and everything. So hope your friends. So if you're confused, if you cannot call me on WhatsApp, don't think of sending a message. I may delay, but those groups are there to assist you, because those groups have pioneers. So the pioneers have all information, how they watch a recording, how they put in a passcode, how they get these documents we are actually using here on Zoom. So you should befriend them, make use of those groups so well. Yeah. Oh, sorry, I got a chemistry book. Let me pick a math book. So today we are going to do some mechanics. Someone is saying they sent me a message and I didn't reply. Please, you give me a call, a WhatsApp call, then I handle your reply there and then. That's my point. So here is our book. So can people see the screen now? Yes, we are now safe. So those who are going to be studying as they are writing, it's better in mechanics. You get your calculators ready, get your rulers. A ruler is the most important thing in mechanics. And we are starting with forces. That is making matters worse, because we have what we call force diagrams in this topic. The moment you draw a force diagram using your free hand, you're gone. So get your calculator ready, get your book ready, get a ruler ready, and of course your pen. Yeah, if you have that, you're ready for the lesson. So we finally begin. So we have said, for the case of mechanics, we thank God that we are now going to begin on term 2 work. Yes. So mechanics is supposed to be a second topic, and you see we start with what they call dynamics. And under dynamics, the very first topic which we are going to talk about today. So if this is a topic, this becomes a subtopic. So the subtopic we are handling today is what they call the resultant. Yes, Solomon. Unmute and speak. Yes, Solomon.
It's like the screen. Something different has been displayed on the screen, not the actual board that you're doing it on.
You're lying.
I'm not lying. Let me read what's on the screen. Are you sure you want to cancel or transfer? That's what's displaying.
Are you for real?
For real, sir.
Hey, what of now?
It's nothing.
Are you sure?
That's okay. It's good now.
Oh, thank you, Solomon.
Welcome.
May God bless you.
Thank you.
They say amen, not thank you. I'm not God.
Amen.
They say amen, not okay, amen. Okay, we are going to look at the resultant. This is what I've been saying. I think I should repeat because people can't even tell how these edits came about. So briefly, this is what I was saying. That we thank God that we are now going to start on Senior 5 Term 2 work. And the second topic in Term 2 is actually mechanics. That's when mechanics are supposed to begin. But you know, different schools can have different plans. So in Term 2, which is our 8th topic, under mechanics, it's dynamics. And the very first subtopic, here we have the term, here we have the topic, here we have the subtopic. So the very first subtopic in mechanics is that the resultant and components of forces. That is the first one. So this one will come later. So I want us to sort that first subtopic. Realize the lessons are supposed to be 20. So just know if we handle it today so well, you have saved like 10 lessons of next term. So in those 10 lessons, for you just be revising as other students are struggling. As simple as that. Now imagine if we also complete the friction and connected particles in the premium class. That means all these 20 lessons will be sorted. What if we also go and handle probability theory, which we are also handling this holiday? That means we shall be saving more 16 lessons. And that's how we shall have saved the whole term. And you will just have to sit, relax, do your work at your own pace, and your A level will be a walkover. Because on top of all these services, your curriculum is abridged. So don't be on pressure. Everything is going to be okay. So that is the introduction. So when I get our book here, let me try to zoom in. Okay. So today is our very first math lesson, and we are going to handle mechanics. So right now, Bright, leave my screen. There are people who just want to disorganize us. Every time they see that we are now settled, we are moving. Bright, remove those green lines you've put in the screen. You're disorganizing your friends. Okay. So mechanics, that's what we are. You members in the chat, you tell me, should I remove these members disturbing us like yesterday? Should I start removing one by one? Remember, anyone I remove doesn't come back. Because personally, I'm tired of them. Okay. My fellow people with bad manners have decided. Now, let me reshare the screen without those markings. The moment they appear again, whoever does so, we remove. Period. Okay. Now, under mechanics, we have agreed that the very first subtopic, our topic is dynamics. And under dynamics, the first thing we shall handle we call components let me use composition, yeah? But components is also okay. Composition, resolution, and resultant of forces. So those who studied forces, you're going to be my fellow discussants. You're going to come in where necessary. So we are seeing a lot of you people, dynamics alone. The word dynamic is the opposite of static. Static means something that is not moving. Then something dynamic is something in motion. So under dynamics, we are going to involve things that are not just there static, but things that have some bit of motion in them. Just understand the meaning of the topic. So our subtopic has 4 words in it. It has the word composition, it has the word resolution, it has the word resultant, it has the word forces. All those are unknowns. So to begin with, I want a friend of mine to first tell us what a force is. Who is ready? Who is ready to define for us a force? Omal Chams, you are risking. I'm going to remove you. I'm telling you the fact. Who is ready to define for us a force? All members can put it in the chat. I read through your answers. Okay, Mary the Great. I'm seeing a planned kid quarreling in the chat. Yes, Ellie, unmute.
So a force is a push off, a pull of an object.
What have you said? Is a push or a pull?
A force is a push or a pull of an object.
Okay, thank you. I'm going to hear from Rachel and Raphael only. Then we proceed. Yes, Raphael.
Yes, teacher. Teacher, a force is an influence that can cause an object to change its velocity unless counterbalanced by other forces.
You make life hard. Yes, Mad Mats. Thank you for the trial, Raphael. You can unmute. Sorry, you can mute. Yes, Mad Mats. What can you say? Yeah.
Okay.
Okay, people have tried. People have tried. Hey, someone has talked about a force being an influence, which is okay. Someone has talked about a force being a push or a pull on an object, which is also very fine. Any other? Okay, we can have those. We can have those. We can have those. Even members in the messages actually have it. Okay. So basically, in math, no one asks you to define, no? We actually apply. So a force, we are going to just have it basically as a push or pull. Just that. Yes. Someone can push a door. Yes, pushing a door. That's a case in point. You can pull a rope. That's also an everyday example. So what you're using is actually force to push a door, to pull a rope. Those are everyday examples. Now, when you were studying physics in O level, did you study things of vector quantities and scalar quantities? Who can tell us the difference between the two? Because now our second question is going to be, which type of quantity is force? So as you tell me yes, you tell me which type of quantity is force. Yes, Berries. Berries, thank you for being active in lessons. I may even give you a bursary. Which type of quantity? Yes, Berries. Which type of quantity? Yes, Berries, unmute. I don't know why people are shy. Yes, Praise Cowton. Unmute.
It is a vector.
Yes, thank you so much. That means people looked at this. Let me see in the chat. Vector quantity. Oh, that means people looked at these things. Okay, that is wow. Now, let's divide this. We are saying it is a vector quantity and it is very correct. Then, our next question will be, what is a vector quantity? What is a vector quantity? Who can unmute? I think when it reaches defining, I'm going to give out some money. But the person giving us the answer, make sure you have an MTN number. If you don't have an MTN number, I'm not going to give you money. Praise Cowton, unmute.
It is a quantity having both.
Before you tell us, do you have an MTN number?
Yes, I have.
Then you define,
It is a quantity having both magnitude and direction.
Magnitude and direction, correct. You read your number.
It is, sir, let me first check for it.
Hey.
Let me first check for it.
I'm disappointed in you.
No, I've just got it.
So she's right, that a vector quantity has both magnitude and direction. That means its opposite scalar only has one of those and not both. Have you gotten the number? It's quiet. So a vector is a quantity. So I will say is that meaning that it is the quantity, is that having both magnitude and direction. Yes. Now I want to ask people, what do you mean by magnitude? Which other word means magnitude? Write it in the chat. So whether you covered mechanics or not, now listen carefully. We are going to hit two birds with a single stone. Yes. Those who learned, you are perfecting. Those who haven't, you are going to learn. Size, exactly. Thank you. So magnitude actually means size. Means size. So who can tell us the unit in which force is measured? You'll also write it in the chat because that is known from O level. You write the name and the name and the short form. The one who is writing newtons with small n, that is not okay. Newtons is someone's name. So you have to use capital N. Yes. And you people, it's not Newton alone. It's newtons. When they are writing units, they make the name plural. Like you can see, the name was Pascal, but the unit is called pascals. Joules, newtons, like that. So we are going to have a note here, just in the middle, and say that the unit for force, is newtons, capital N, like that, newtons. Then appreciate, this one is supposed to be capital, capital, this is small s. As simple as that. Those are the three things that you should put on. Now, about the size, what do they mean by size? Yes, we've learned that their forces are recorded in newtons. What is the size or magnitude? How does it look like? So when I say size, say 2 newtons, someone just says 2 newtons, 5 newtons, 25 newtons, 50 newtons, etc. Yes, that is the magnitude. Just that alone. Then someone may be asking, we've learned that that's how the magnitude looks like. Then what is this direction thing? How do I know that this is the direction that has been talked about? Something like that. Now, the direction, they rarely, okay. How do you know the direction? Listen. One, they can use, let us write those statements, because I believe there are those serious people of mine who are trying to copy notes, so that when the term begins and the teacher is going to introduce forces, they just get out our notes. Then they just try to follow up, adding in what the teacher has added, like that. So we are going to say that for direction, they can use one, left or right, trying to give you direction. They can use vertical, stroke horizontal. By right, you all know that right faces the other side, then left faces the other side. You all know that vertical is like that, then horizontal can be like that, either in the right or the left. Even vertical can also look down like that. Horizontal can also, you understand? All these are directions. They can use north, they can use east, they can use west, they can use south, they can use northeast, they can use southwest, and etc. Me saying etc doesn't mean that you add on your one notes. You now write southwest, east, east, west, northeast. That is enough, and etc. We are going to be looking at a lot of examples. Then the fourth, sometimes they can use angles. You understand? Maybe they say 30 to the horizontal. Now these ones are for the big dogs in the subject. The moment you are in position to interpret such information, you are a big dog in mechanics. They can say 45 degrees to the vertical. They can say move from the north, move 30 degrees towards the east. Then they can say move from south, move 200 those degrees, 270 degrees, maybe towards the what? The west. etc. All those are formats for direction. So before I actually proceed, I want to ask members in the chat whether we are so far together. That's now the broader view of what magnitude is and how direction may come in, and which words do they use for direction. Are we together so far? Your friends have started calling me. Tell people in the groups not to call me. Tell them, doctor said don't call him, we are busy. Just tell him stop calling doctor, we are busy. They wait for when the lesson has started, then they start disturbing. Okay. We are together. That's nice. So you can proceed. Who is this one again asking me for advice? Oh, the good thing you've sent it as a private message. If it was to everyone, people would be laughing at you. Someone is like, the mothers just abused them because they posted their boyfriend on status. You tell your mother that you are also dating my father. Hey, you tell your mother that my father is also your boyfriend. Why do you interrupt my things? But I don't advise you people to post your boyfriends. Even girlfriends, it is not good. Let me tell you, one time you'll be disturbed. You'll be tortured psychologically. I told you there are friends who are there to torture you mentally. You will post your boyfriend and put there a caption. Put there babe. After putting babe, there is a friend who is going to view your status there and then. Now, after watching, they now go on their status and type. They say, but the things some of you call babes, hey, and they will call your boyfriend or girlfriend things. But the things some of you call a babe, let me tell you, you can be tortured for the rest of your life. You'll just end up breaking up with your broker boyfriend just because of people's words. So the parent is right to quarrel. Please take their word so that they don't call your boyfriend things. Okay. We have just started and someone wants a music break. Please log off enemy of progress. Fire. Okay, now let's talk about arrows so that you also learn them. How do we use arrows in this subject? How is force written? Then we draw some forces, something like that. So we write so to apply what we've done, for newtons to the left, we are going to draw some things. Then we can have 1 Newton to east. Then we shall also draw 10 Newtons to the west. Then the other thing I forgot to tell you is that about this direction, let me just put it here besides in red. It can be our 5, yeah? It can be our 0.5. Then we bring in the etc. So direction, they can use negative or positive. Let me use a slash. Negative or positive. etc. Yes. On this side, we are going to draw horizontal vertical 30 newtons. Then we can also have a vertical force, but maybe negative 4 newtons, something like that. So we are going to begin the drawing. Now the first one is 5 newtons to the right. You know, some people are Muslims. So let me ask, of the first arrow and the second, which one is to the right? Some people are Muslims. I want in the chat. Which one is to the right? People know it. So when they say 5 newtons to the right, you have to do this. You put the arrow, then you say 5 what? 5 newtons. Yes, like that. 4 newtons to the left, you can do this. Then you write 4 newtons. There are people who prefer putting the forces on top of the line. It is okay. There are people who prefer putting the forces after the pointed arrow, which is okay. 1 Newton to the east. East is the right. Saying 1 Newton. Then 10 Newtons to the west. And the west is the left, I think. Yeah. They are saying horizontal but negative. Horizontal force is like this. So if it is negative, is it going to look this side or the other side? Is it the first arrow or the second arrow? Horizontal but negative. Is it the first one, the second one? Horizontal but negative. Horizontal but negative. Yes, with the ruler. I mentioned that in the beginning. That mechanics, all these things are supposed to be drawn with the ruler. I wanted to get my ruler, but it could waste our time. So horizontal -3, we have agreed that it is looking this side, -3. Now you people, forces are never negative. This negative is there to show us what? Direction, as we agreed. That's why even on the arrow, we don't put there left -4. So we don't put there left 4, we just put there 4. Why? The left is there to give us what? This left is there to give us direction. So even this negative is just there to give us direction, but the arrow should only have the size or the magnitude of the arrow. So I don't want someone to be like, but doctor, where is the negative? Force cannot be a negative. So 3 newtons. Horizontal 5, that is positive, so it will look the other side. We can put our 5 newtons at the end. Then vertical, positive. So vertical, they are always like that. It can look down, it can look up. So first one, second one. Which one is positive for vertical? First one, second one. Yes, it looks up. So if it is looking up, then it is the first. You people know mechanics. Then why were people saying that we should do mechanics with all the content you have? I've actually just realized that the people who said mechanics is hard didn't see you coming. Vertical negative, it will look down. Then you don't put the negative. The negative is just there to show you what? Direction. So, you realize a vertical which is looking up, someone can say 13 to the north. Then if it is a vertical negative, someone can say that these are 4 newtons to the south. Yes. And everything is correct. No problem. Yeah. So those who are saying they have issues with those words, I think now they are put right. Those are some of our few forces we've tried to draw. Now, we have defined a force. That is learning objective 1. That one is done. Now, learning objective 2 is you learning the components. So learning objective 1 achieved. You now know how to draw different forces. Now we go to the next. Next is learning objective 2. And what's that? Components. Components of a force. Are you seeing Zoom user? Zoom user, if you don't remove that line, I'm going to remove you from our meeting. That's what we agreed with my members here who have bad manners. So you better remove that green line. Thank you. You have survived. So about components of a force, I want us to assume. Now, Justin, remove the red line from the screen. What do you really want? Why don't you get your own time? You log on Zoom and do whatever you want. Why do you wait for classes and you disorganize us? The next person, I think we should just turn on their videos. We see where they are. Now this Pearson Pith also wants to be talked about. Let's assume you are pulling a suitcase at an angle. Let's assume you are pulling a suitcase. Let's assume you are pulling a suitcase at an angle. Let's assume that you are pulling a suitcase at an angle. I'm not so good at art, but we can try. Let's assume that you are pulling a suitcase at an angle. Please don't laugh. Yeah, but this hand is very long. Let's try to do this. This is our ground. Yes. So let's assume that this is our suitcase. Yes, assume you are pulling a suitcase at an angle. Get black. So I'm like, this is the suitcase, and that is the force you are using. I want you to listen carefully. What is the angle I'm talking about? Just draw that. Just draw that. So I'm not sure about the angle I'm talking about because I can have two cases of the angle. I can have the angle with the horizontal, then I can also have the angle with the vertical. So the angle with the horizontal is this angle in red. Then the angle with the vertical is that angle still. I think you've seen people. For me, I'm always at the airport, especially when I'm going for content exhibitions in Kenya and South Africa. I always see these people on the airport. I look at them and be like, these people are joking with scenarios. You wait for one of the scenarios, I'll give you this holiday. That will be next week on, or you may even do it in the end of Halloween Wekekism. I'll give you an image of someone that is pushing a suitcase but at an angle. Then we develop a lot of questions from there. So we have said this is what we call the vertical. Then this is what we call the what? The horizontal. So you can be pulling that suitcase at an angle. So I'm going to call this first one theta. I'm going to put here theta. theta, our angle, at an angle, say theta. So what do I mean by a component of a force? The person is now complete. Yeah. Now, this is going to be our force F. I want you to listen carefully. Resolution of forces is applied in all topics of mechanics. So you need to understand this. So, this person is using a force F. Let us even is using a force F to pull. Is using a force F to pull. So you realize why a force is called a pull or push. To pull the suitcase. What next? The force F has two components. The force F has two components. As you can see, it is acting in the middle and it is having the first component is the vertical component, which we are going to call VC, just VC. Vertical, we are going to give it that direction. Just VC to help us see it. I think people can see the VC, meaning vertical component. Then the other component is the horizontal what? It is the horizontal component. And I'm going to, it is looking this side. So I'm going to represent it with HC. So I'm going to put here a small h, like that. So first appreciate what components of a force are before we proceed with other things. It is the long objective, but I've just started. I've not said anything about the component of a force. Not. But first assure me in the chat that you know what a component is. You know the vertical and horizontal. You can represent them on a diagram and you're actually seeing them. You're seeing the angle, you're seeing the force the person is using to pull the suitcase and so on. So are we good to go? Are we good to go? Okay, I think everything is okay. Now look here. So if we are to make the diagram better, we shall put a dot. We show this force F, which is in newtons. We show the horizontal component. We show the vertical component. Like that. Now, we are going to first recall something little. We are going to first recall something little. And what is that? Trigonometry. Do you have people who know nothing as far as trigonometry is concerned? Did you do trigonometry in O level? Because if you did it, then it's nice. Did you do trigonometry in O level? Trigonometry in O level. Did you do trigonometry in O level? Now, some people are saying yeah, others yes, others no, others yes. Okay, we are going to find a way. Now, that means we have now to delve into now. Assume we have this triangle. Don't worry, we are going to sort everything. Assume you have something like that. Don't forget to use a ruler. Then you have this angle. Assume we have a right angle triangle. You people, I want you to leave this place when you are good at resolving. So you listen, we have a right angle triangle. Then I also give you a hint before we proceed. So what is the hint? The hint is that we use the angle. The hint is that we use the angle. We use the angle to name the sides. To name the sides of the triangle. You people who are saying that you know nothing about tree, listen. At least you know what a right angle triangle is. So I'm giving you a hint that we use the angle to name the sides of the triangle. We use the angle. Someone may be like, now which angle? You're going to see our angle is going to be angle theta. You're going to see it. It's going to be our angle theta. So we can now draw the diagram. So this. Don't forget to use a ruler. So you can see our angle theta. It's right angle triangle. So we expect a right angle there. Now, this side that is opposite to the angle, I see where the angle is facing. You know, if people can see that. Where the angle is facing is what they call the opposite side. It is the opposite. And how do we abbreviate it? We abbreviate it as what? OPP. And what have we said? We have said this is the side theta faces, or the side opposite to theta. Those of you who went to good primary schools, you know the meaning of opposite. When you're opposite something, when you're using your phone, you're opposite to it, so you're facing it. When they tell you go to building X opposite a mosque, that means those two are actually facing each other. As simple as that. Then there is this side where the angle is lying. And this side is called the adjacent, this one. Adikini imi, remove your line. This is called the adjacent. And we abbreviate it as ADJ. Yes. And what is so special about it? It is that one side. It is that one side where our theta lies. Or someone can say where the theta sits. So if you look at that diagram well, the theta is sitting on the adjacent, or it is lying on the adjacent. Then the other remaining side, that one you know it from baby class. Those of you who went to international school, you all know it is the hypotenuse. 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 Which we abbreviate as HYP. And why is it so? What is so special about it? It is the longest and slanting. First and foremost is the longest. Then second, it is the what? Is the slanting. What does that mean? You can never find the opposite slanting. You can never find the adjacent slanting. As simple as that. So, what next after that? We are going to redraw. Now let's have a redraw. And then I tell you what I want. So a redraw. A redraw, we are going to have our theta. We are going to have our hypotenuse here. We are going to have our opposite, where the angle is facing, or the side opposite to the angle. Then the adjacent, where the angle is sitting or lying. And hypotenuse, the longest and what? And the slanting. Now, we use SOHCAHTOA. We use SOHCAHTOA. Let me see people who don't know SOHCAHTOA. Let me see the people who don't know SOHCAHTOA in the chat. If you're there and you're hearing SOHCAHTOA for the first time, you say, for me, I'm hearing it for the first time. So we use SOHCAHTOA to bring in the trigger identities. The sine, the cosine, and the tangent. But as usual, for me, I will not forget of I will not get tired of giving you the abbreviation. This one is abbreviated like that, but we read it as sine, not sin. Then this is cos. Then tangent is tan. Those are the abbreviations. Let me see those who are hearing SOHCAHTOA for the first time. Here, sir. Me, I'm hearing it for the first time. Hey, really? Hope it's not a joke. Remember SOHCAHTOA. Okay. How does it actually work? You listen carefully. Hey, how does it work? So, I will come and use the first one. It is SOHCAHTOA. So I have my so. What does so mean? This S is for the sine. So sine of this angle theta is the opposite. You can see that way. Is the opposite out of the edge, the hypotenuse. That's what it means. That's what it means. So alone. S is for sine, but sine cannot be written alone. When you press sine in the calculator and press equals, it is going to bring math error. Not until you put there an angle, maybe sine of 90, sine of 120, sine of 360, sine of 1000, like that. That's when it can give you a value. But sine alone is invalid. So that's why you put on sine theta to show that this is sine of an angle. It has to happen. So I think people, you've seen how this is done. So who is that bold student to tell us about the car and the tower? Who is ready to tell us about the car and then about the tower? Someone tell us about the car and the tower. This is car. And then here we shall have the tower. Let me see. Solomon Mukisa, you have over raised up your hand and have not been choosing you. Yes, Mukisa Solomon. Yes, Solomon Mukisa. You're quiet again. Yes, Grim Reaper. Grim Reaper.
I'm talking about the car. The car
Yes,
is cos
the
theta.
car.
Cos theta is equal to adjacent over hypotenuse.
Yes. This C is for cos theta. Don't forget the theta after the. Then this A is for the adjacent. Don't forget the out of hypotenuse. So the last H is for the hypotenuse. Simple as that. Then lastly, the tower. Okay. Namwase. Jennifer Peace. Unmute. Hey, today people are active and I like it.
Well, the tower,
Mm.
T for tangent,
Yes. Which is
and
abbreviated as tan.
then to get tangent of angle theta, we get the opposite out of the adjacent.
Thank you. That is it. F for opposite, F for adjacent. So all in all, to summarize it up, remember SOHCAHTOA. Remember SOHCAHTOA. Yes. Recall that sine of any angle theta is opposite over hypotenuse. Cos of any angle theta is adjacent over hypotenuse. And tan of any angle theta is opposite over adjacent. Okay, I've tried to pinch for you the screen so that you follow up, because whatever is coming, I can't see anything. Bananga, I'm missing. Okay. Now, hope that is okay. Hope that is okay. Now, we go back to our person carrying the suitcase. Hope you call that person, because now we are going to bring out the facts. Now we're going to say let me put some trials here. Trials. Let me put here 30 degrees. Yes. Then I say this is 5 and that is x. Find x. That is A. Then B. I will have here A. And I will have 45 here. Then here I will have 3. Then I will say find A. Solomon Mukisa, why you don't get tired of raising up your hand? And then when they pick, you don't say anything. 60. Then I'll put here P. And I'll put here 2. Then put here root of 2. Then I'll say find the P. Now, before I calculate, we are going to do this together. You listen. We are going to do this together. We said you name these sides according to the angle. You don't just name them anyhow. You name them according to the angle. So I have a question. Have an ask. What is this 5? The opposite, adjacent, hypotenuse. The 5. What is the 5? What is the 5? What is the 5? I want only 10 people. 10 people. 10 people. Yes, those are enough. Those are enough. Don't write more answers because we are now going to another question. So it is the adjacent. Why the adjacent? That's where the angle is sitting. Then x. What is x? Is it? Then x. You people, you just send the letter to save time. Adjacent is A, opposite is O, and hypotenuse is H to save time. Oh, yes. That is enough. I'm asking another one. So this one is OY. That's where the angle is facing. We go. According to the diagram, what is this A? Very fast. What is the A? The 10 people are done. It is the adjacent because that's where the angle is sitting. Very fast. What is the 3? What is the 3? The 10 people are done. We go. What is the P? This P on the third diagram. Let me see if people can see that P is where the angle is sitting. So show the 90-degree angle. You see, I'm seeing some people fixing A's. You people, the hypotenuse is always slanting. Hey, something that is not slanting cannot be the hypotenuse. Yeah, so people have passed. Then what of this root 3? Sorry, the root 2. What is the root 2? Just a letter, just a letter. Oh, yeah, thank you. You people now know these things. So I think you can see that as you're trying to solve such things, you should first know what you have. Is it the adjacent? Shannon, you tap in the screen and remove that green line. You know why you're disorganizing us. Shannon, remove that green line you put in the screen. Because the moment I remove it myself, you are bringing issues. Now I said Shannon, now Sharon wants to add in other things. The name was Shannon. Okay. I'm going to put Sokatoa here. Sokatoa. Hey, according to Sokatoa, which one are we using on the first diagram? Are we using S, C, or T? S for sine, C for cos, T for tan. You just send the letter. First diagram, are we using S, C, or T? Thank you, it is T. Now we go. How do we calculate this? So come and say tan. Come and say tan theta is always opposite over, because it is the toa. What is the theta? Theta is my angle, 30 degrees. What is my opposite? It is x. What is my adjacent? It is my 5. You see? Hey, then you be like, they want x. X will be, math has it that when I cross multiply, my x will be 5 tan 30. Those with calculators, you send the answer in the chat. Hope people are following. We have now started real business, real mechanics. Real mechanics. You're going to squeeze it today, don't worry. Now someone wants to write there the answer. You be disciplined. I've not asked you to. What is 5 of tan 30? For me, I always write my answers to 5 decimal places. Let me see if I have a relative. Yes, I have a relative, that is Bon Olupot, Jackie, Agnes, Zumius, and Precious. Yes, I have relatives here. Even me, I prefer 5 DPs. So we have the same test for the subject. So it is 2.88675. Yes. Second drawing. What are we using? S, C, or T? Second drawing. Are we using S, T, or T? Second drawing. I want 10 people. Those are 5. I don't know why people are sending S. People are not serious. S as O. But for us, we don't have O here. So we are using C because we have A and H. Yes, so we come and do the math. Yes, we come and do the math and say, that cos theta is always A over H. Don't bother yourself with writing full statements. No one is interested in the A over H. This is just to guide you. So cos of theta, our angle is 45. Then adjacent is small a. Then our H is 3. Very clear. Then math has it that for us to get A, shall need 3 cos 45 degrees. So our serious people with calculators, what is the value of A? Emmanuel D, if you don't remove those lines in the next minute, I'm going to remove you from the meeting. Thank you. Stop assuming importance during our lesson. What is the value of A? 3 cos 45. Yes. 1, 2, 1, 3, 2. 1, 2, 1, 3, 2. 1, 2, 1, 3, 2. Wow. Now, let me see in the chat those who are with us. Even I want to see those who are with us and those who are not with us. You type in the chat, I'm with you, teacher. You type in the chat, I'm not with you. I see the progress. If you're with me, you say, I'm with you, doctor. If you're not with me, you say, doctor, you left me very far. I'm not with you. I'm with you, 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 I'm with you. Those are enough. Yes. Now, those who are saying you're with me, I'm not calculating the last one. You just give me the answer. Yes, so this is going to be an in-class assignment. Yes. So you just send me the value. In-class assignment. Just send me the correct value of P. People are done. How come? This is an in-class assignment. Tell me the value of P. Let me also calculate it. I'm not going to trust people. What is the value of P? I've realized some people are using cram work. Some people are just getting, most of you have it right, but there is that percentage that is just multiplying things. They have just even used the phone. You people, you do some math. Some of you just think we get the value there time was maybe cos or sine of whatever the angle is. No, please. Here we have O and H, so we are supposed to use sine. So you have to say sine theta is O over H. The angle is 60, which is sine 60. The opposite is root of 2. The hypotenuse is a P. So why are you saying? So why are people saying the answer is 1.2 something? That is not correct. So from there I realize you have to cross multiply. But I told you some days back that here we don't show the steps of cross multiplying. You do it. So when you cross multiply, it will be P sine 60 degrees equaling to root of 2. So for you to get P, you have to actually say root 2 out of sine of 60 degrees. Please, the degrees must appear. The moment you forget the degrees, you are gone. That's why for me, I'm not forgetting them. When you don't put degrees, everything changes and you fail the number. So when I do that, I get 63299. Hope that's what most people have. 63299. Are we together there? Yes, that's what people have. So here I'll just put for you a note in form of a reminder that please never forget. Never forget the degree on the angle. You bring yourself issues. So realize we have even revised some trigonometry. So when I'm teaching trigonometry, I will not even find issues. That is to say that when you write 30, don't forget this degree. This is what I mean, kano. That is the degree, don't forget it. Otherwise, things will have changed. Yeah. So now, I'll give you a 3-minute break. Then we go back to our person of the suitcase. I told you what breaks mean. Breaks mean those who still have issues, you stay on. For us, we keep jazzing. Then don't log off. You're not supposed to log off. You stay on, ask questions. Let me play for you some academic song so that people rest a bit. Just relax for meditation. Even people know what meditation is. You meditate and think about your studies. Meditation. Meditation, you just relax and meditate.
Do you have trouble falling asleep? Download Sleep and get a break. Fight insomnia and anxiety.
But some motivational speakers are not easy. Someone is busy on an advert saying that it is possible to actually download sleep. So that is the sound for meditation. You can meditate as you ask your questions in the chat. Then I address them. That is the academic music. I'm seeing someone abusing the motivational speakers, but I also joined the motivational speakers. Yes. And my first script was, it had the heading, Life is a Yam. You will enjoy it. I'll share it so soon. Life is a Yam. I also joined motivational speakers. And let me tell you, it's going to be nice. All of you, that is a must read. Life is a Yam. For motivational speakers, the titles are easy. Then I'll make another one. Life is a toe. And I also talk about that. Life is a bucket. I motivate people. Very possible. With us motivational speakers, titles for our scripts are not hard. I can even decide. I can even decide to use body parts. I be like life is a nail. I forge a story. Life is a muscle. Education is a scam. Yes, life is a bucket. I can even say life is a scrotum. I use body parts because I'm a doctor. That is okay. Okay, Prince Carlton wants to say something. At the same time, my Swahili girlfriend is calling. So for me, I always prioritize academics over everything. So praise Carlton, unmute and speak. Let me ignore the Swahili girlfriend. You people did the Swahili culture, so you know what I'm talking about. Praise Carlton, unmute.
So I've been asking about the payment. So if you are paying in installments, it's like after how many days do you pay? Like after how many days you pay?
You can pay in installments the whole holiday. You refuse to pay balance, I bewitch you. I bewitch you. If you're a boy, out of the blue, you just hear your scrotum itching. And it will always itch on its left side only. Yes, for me, I have my ways of bewitching my people. For girls, I don't bewitch. I just handle boys well. Boys, you just see out of the blue, you have two testicles. So the right testicle will be expanding daily. And it is only the lower part that will be expanding. These days, charm has been so developed. So don't joke with installments. You refuse to pay, we handle you traditionally. That is the thing. I'm telling you facts. Yeah. So installments, you just pay. Don't worry. But don't worry, you pass these things. Composure is key. Just like in outside life, it is the same in academics. Composure is key. Like my friend today was narrating, he was in a taxi. Then one of the are they passengers? Someone called the passenger. Then as the passenger was on call, the passenger told the person, wait, I'll call you back, I'm driving. Yet the person is in a taxi. So composure is okay. You fake the academic life and life moves on. These are things that won't matter in heaven. Scroll up from the suitcase guy. Okay. I think the 3 minutes break is done. We can proceed. So back to the suitcase guy. So this time around, we are going to draw a more improved document. Sorry, diagram. Yeah? So the person was, assume this is now our suitcase. Those who are with us, that's the suitcase. People, the break is done. Then this is the force. You understand? That is the force. It was F. It is the force the person is using to pull the suitcase. Then we said we have a vertical component. Then we said we have a vertical component. we have the horizontal component like that. That's what we are saying. And this is the force the person is using. Let me try to redraw it. This is the force the person is using to pull the suitcase. Our force is F. Then we said it has this vertical component. It has this horizontal component. Mugaga John, leave my screen. Remove the red line. Now, I want you to learn this today. We said he's doing all this at an angle theta. So I'll put there theta. Then I want people to recall that just put it here down. I want people to recall that this is what we call the x-axis, or what people just show as x. Then this is the y-axis, what people usually show as y. So the force F has a vertical component, which vertical component is also a force. You understand? It has the horizontal component, which horizontal component is also a force. So we shall say this horizontal component on the x-axis is our force x. Then this vertical component is our force, but in the y-axis, Fy. So I don't want to see someone asking, what is the F? What is the Fy? What is the Fx? Everything has been explained. You get? Now, after this, we are going to convert this. Convert it into the whole of it. We are going to convert it into a right-angled triangle. A right-angled triangle. And what is going to happen when we convert it into a right-angled triangle? We shall have that. I'll have the theta here. I want you to listen carefully. Have this here. We have our force here. You can have this force here, Fx. You can now have this force here also, Fy. And that is the most important diagram. Most important diagram. If you don't get that diagram, then mechanics is going to disturb you for the rest of your life. That is the most important diagram. That is the most important diagram, and I'm going to comment about it, Kalito, again. I know this one is okay because it is here. That one I've ticked with that color. Now I'm going to get my black color. I believe even this f of x is also fine. It is obvious. But the problem may be on that Fy. How is it again reaching the other side? So this is the trick. So that Fy, it is a vertical force. So it can also appear somewhere here. You get? It can also appear somewhere there. It will have its arrow. It can be our Fy because it is vertical. So it can be anywhere on the plane. If we are looking at how we can convert this into a what? A right-angled triangle. And this is what actually matters. It is the most important diagram. most important diagram. Without it, resolution of forces is going to disturb you for the rest of your life. So before I go to the most important part, is that diagram okay? The one we have obtained after doing all the conversions. Is that diagram okay? Because without it, then whatever we have been doing is a wastage of time. So I really need to get feedback from you, whether the diagram is okay. Then we proceed. Now we are going to bring in SOHCAHTOA. Because you cannot apply SOHCAHTOA on the first diagram, you can only use SOHCAHTOA on a right angle triangle. That's why there is need for the conversion. Someone is like, yes, but what does fx and fy mean? Who can explain that to Alvin Pro? Alvin Pro is asking, what does fx and fy mean? Who can explain as I redraw the diagram? If you can elaborate that. Yes, Emmanuel, unmute and explain to him. Yes, Emmanuel. I'm really tired of you people. You raise up your hands, you don't talk. Ugh. Yes, Rachel. Anyone who sees the thing first, you talk.
Well, according to what I know, when we are resolving, we have what we call resolving for x and resolving for y. So the f is like function y and function x, something of that sort. Yes.
That's not what I said. That's not what.
Okay.
Please,
Doctor, I think you said that the fx means the x axis, the fy is the y axis.
yes, that is it. The x and y are there to show us direction. That f of x means the horizontal component because the x-axis is the horizontal axis. Then the vertical component is on the vertical axis. Which vertical axis is the y-axis? As simple as that. No big deal. Y-axis is what we always call the vertical axis. So it will be in line with the vertical component. Then the x-axis is the horizontal axis. So it will be in line with the horizontal component. Axis. So please, those who are unmuted, please mute. Horizontal axis. So you get vertical axis, vertical component. Horizontal axis, horizontal component. Okay. Now, I have a simple question. This force of ours so let me assume. So we are going to draw another one. We are going to assume that force of ours, please Dawkins, you remove that blue line. Please, you people, leave the screen. Dawkins, remove the blue line you put in the screen. People are just big-headed. So assume the F is 5 newtons and also assume that the theta is 30 degrees. So we are going to work together. Put here 30. Put here 5 newtons. Put here our horizontal component. Then we put here our what? Vertical component. Please, Mama something. Leave the screen alone. So I have my questions. My question is part A, to find f x. Part B, find f y. Like that. We are just assuming that our f is 5 and our angle is 30. And they need the fx and fy. The best thing here is to split. What do I mean? Draw the diagram for capital F of x when it is having x, when it is having f of x alone. Maybe put here the 30. You put here the known value, this. Then you put here only f of x, like that. Then you draw another one with fy. Leave here 30. You draw this force f. Then you come and we get f of y. This time round, I'm not going to name things of opposite, adjacent, and hypotenuse. Just tell me, which one are we using for the part A? Are we using sine, cos, or tan? Then also tell me part B. Are we using cos, sine, or tan? So you say part A, cos, part B, tan, part A, tan, part B, sine, like that, in a single message. So people, in whatever you're doing, don't forget the right angle, because I told you we are converting it into a right angled triangle. So don't forget the right angles. Don't forget the right angles. They are very important. And in case you miss them, you can be penalized. So back to our two diagrams, you tell us what to use for part A, whether sine, cos, or tan. Same for part B. Let me see if people have the same answer. A cos, B sine. A cos, B tan. I don't know why in the last one people are saying tan. Tan is opposite and adjacent. So I'm wondering, you cannot use tan at all. You cannot. Because tan doesn't need the hypotenuse. And in both cases, we have the hypotenuse. Yes. So here, this side, we are using cos, as people have said. So I'll write and say cos theta I'm really tired of side work. Let me do it for the last time. So this is your adjacent, and this 5 is your what? Hypotenuse. So you're supposed to use cos and say cos theta is adjacent over what? Hypotenuse. Then you say cos 30 is adjacent fx out of hypotenuse what? 5. Yes. Then what do you get? Fx is equal to 5 cos 30. Those with calculators, what do we get? Those with calculators, what do we get? Now these are things we were doing. So I don't want people to act as if things are now becoming harder. Yes, I'm getting 4.33013. So I'm getting 4.33013, and these are newtons. Yeah. So you come and get a score. Nice. Then when you come to this, people said we use sine. So someone may be asking why sine. This one is the opposite because that's where the angle is facing, and this is the hypotenuse. Okay, so we come and say sine of any angle is O over what? H, just to guide you. With time, we'll even ignore that first step. So sine 30 is opposite, which is F what? Fy. Hypotenuse, which is what? 5. So what do you find out? That finally f of y is 5 sine what? 5 sine 30. Then those with calculators, I'm getting 2.5. Hope that's what you also have. It's a very correct answer. Yes, 2.5 newtons. Don't forget the newtons because we are dealing with forces. Now, that diagram teaches us something important. So I'm teaching how you come up with the vertical components and so on. Yes, and it is the most important thing. It is the most important thing. If you can understand that, things become easy. Now, what we extract from this is here. Are you seeing this part? And this part? Those two things are very important. Why are they important and what do they have in common? All of them, you realize they have the 5, even this one has the 5. What else? All of them have the same angle 30, even this one has the angle 30. Listen carefully. But what are the differences? The difference is that this is x and this is y. Then the other difference that this is cos and this is what? Sine. So the differences are obvious because those ones are common. Even the similarities. But I want us to make a statement which is a life-changing statement, and you have to be serious about that statement. Hey, realize we have the horizontal component, we also have a vertical component. But how have they been obtained? It's what I want you to learn today. So you see the similarities. The similarities on the 5 and 30, which 5 and 30 were just assumed, if you recall, it was just an assumption. You can see here, we assumed that theta is 30, then we also assumed that the F is 5 newtons, and they are the similarities. What it differs is that one is a horizontal component and the other is a vertical component. And one we have used the cos, then the other we have used what? Sine. You listen carefully. Because not every time we are going to be drawing the right angle triangle. No, you need to learn the concept. And this is the concept. So every time you have this angle like this and you have a force here, F, you listen, F, and you need this component. So it is Fy because it is a vertical axis, which is the y-axis. And this is F what? Fx. You listen. Resolving this force, what they mean by resolving, if you need this horizontal component, if you need the horizontal component, capital F, small x, this one here. You know the people seeing it, the one I've put the red arrow on. If that's what you need, you will push the force like this. And then, if what you're looking for is the vertical component, this one with a green arrow, what you will do to this force, you will move it like that. I don't know whether people are understanding what I'm saying. Remember, it is initially a single force F, which single force F is being used by someone to pull a what? A suitcase. Now you are going into other tasks of getting the horizontal component. The horizontal component is f of x, and I'm saying if you really want the force to become the horizontal component, you pull it like that in that direction because you're forcing it to be a horizontal component. You want it to lie flat. That's what you do. Are you listening? Then, if you want to get the vertical component, the one with the green arrow, you are trying to make that force straight. You want it to face upwards. That's what you do to that force. You pull it, trying to make it straight. You understand? So, what have I said? I've said that here, you are pressing theta. You are pressing theta. Or someone can say, you are moving towards theta. You are moving towards theta. Then, this side where we have green, we are not pressing, we are moving away from theta. So this side, someone can say, moving away from theta. Because you're trying to make it straight. You are trying to move away from theta. But for the horizontal, as you press it, it's like you're moving towards the theta. Then the other one, as you're trying to straighten it to become vertical, upright, you are like moving away from the theta. Now, when you're moving towards the theta, pressing it, you are pressing, you are compressing. I don't know whether people are getting. You are pressing the theta. You are compressing it. You are compressing the theta. You are pressing it. We use the cos. We use the cos because we are pressing. We are compressing the theta. Cos. Then the other one of moving away, of course, automatically takes on the sine. So every time you are pressing theta, moving towards the theta, compressing it, it is supposed to be cos. Then when you're moving away, it is sine. And the format is very easy. For us, we realized that even when it is f of x, the horizontal, or when it is f of y, the vertical, what did we realize? We realized that the angle doesn't change, the angle is 30. Even the force doesn't change, it was 5. Isn't it? But what changes are these things, whether you have cos or sine. Those are the only things you're supposed to understand. So when you look at f of x, it is the horizontal. For you to form it, you be like pressing the theta, compressing it, compressing it. So we use the cos. You have the knowledge from first principles, now get the cheat code. Then of course the other one will be what? Sine. So when you realize that you're not compressing the angle, it is sine. When you realize that you're compressing the angle, it is cos. As simple as that. So what does not change is the angle and that diagonal force. Ebyo byo tebikyuka. They don't. F originally, F originally. 30 degrees originally. But this time round it is theta. Put theta, theta originally. I'm compressing to get horizontal cos. I'm compressing to get Fy sine. And this is the thing. That is the game of the topic. Everything I've been teaching, you can forget whatever I have taught today. But I beg you, let me even first get where to kneel. Should I turn on video? I kneel? Because I really want to beg you that in whatever I've taught, you can forget other things, but don't forget this. Should I turn on video? I kneel? Because people may think I'm joking. The problem, I'm at the ward and you may see dead bodies, and some people may have trauma. If you don't have phobia for dead bodies, it is okay. But I really want to beg you, those two things, please don't forget. Don't forget. Let me see if people. Yes, Zacharias. What are you saying? So
I'm
people, I
saying
beg you.
I got the concept very well, though I came late.
You got the concept? Hey,
Yes.
thank you, Zacharias. Appreciating. So make sure you get money for paying, so that you
Welcome.
don't miss more lessons. Because we are supposed to complete mechanics for term 2. Go back and teach your teachers.
It's okay. It's okay, master. It's okay, doctor.
The doctor, not master. I'm not a teacher of karate and kung fu.
Yes, doctor.
You are not a teacher. Yes, Alvin. Unmute.
Hello, sir.
As
I have
other
a-
people be looking on the board to make sure that the point is clear, because I'm bringing harder questions now. Yes, Alvin.
Hello, sir. I have a question about the operation of the calculator, because our teacher told us when we are using trigonometry, we need to turn it into radians, something like that. We need to first.
That one is done in paper 1, but you only turn to radians if the 30 is not an angle. But if it is an angle, meaning it has a degree on it, so your calculator is supposed to be in degrees. But if it is any other angle without a degree, that's when we put the calculator in radians. But any angle in degrees, even the calculator is supposed to be in degrees. You get the point?
Sir. So it's basically in paper 1.
Yeah, that's where those things are mostly. But in paper 2, they are rare.
I get.
Okay, sir. People have a lot of questions. Yes, Achelam Alfred Oloya. Names of men who beat women. Achelam Alfred Oloya. What do you have to say? Yes, Queen Milady, the last one. Then we proceed. As other people look through the page to make sure everything is on point. There are some people I will not choose again. You choose them, they keep quiet, and they do it continuously. Ever since I started choosing Queen Melody, she has never said anything. She has
Excuse
never
me.
said to even cough.
Excuse me, sir.
Wanji. Yes, Acheram.
Yes. Teacher, you had said. Teacher.
Yes.
You had said that when we're using, like, when we turn our calculators into radians, it's only in paper 1. But for us, we were told when you turn in calculators into radians, you're supposed to use it when you're doing interpolation. I mean, that topic of interpolation.
That's not what I said. I said
What
it is
have you
mostly
said?
1. Then after that, I added that even in interpolation, if the angles are in degrees, you're not supposed to put your calculator in radians. Radians mean that we don't have a degree there on the angle. That's what it means, as simple as that. You get the
Okay,
point?
yes.
Okay, madam. Banange, those are enough. We can, I think, proceed. You share the link and friends join, because what I'm teaching now is supposed to come in your UNEB. Whatever I'm going to do next has to appear in your UNEB. So share the link, advise members to log on. Now, what I'm going to talk about must come in your UNEB. You like it or not? Let me see if people have gotten the concept. We go. 30A. Don't forget the direction thing, please. Don't forget the direction thing. It is very important and paramount. Okay. Let me first do this. Have a particle here, particle there, particle there, particle there. Like that. So I'm going to put, so this time round we are not going to draw. We are not going to do a right angle triangle, no. That one is for beginners. And now you people are not beginners. Yes. And this time around, I'm not going to use PX, FX, no. I'm going to use P and Q. Let me see if people have the idea. Who can unmute? You tell us what P is. You tell us what Q is. Who can unmute? Okay, let me first do this for you. Then you do the others. You listen. You listen. For P, I want us to go slowly. Slowly. Let me even first note. We are going to move slowly. Slowly. So you listen. We are going to move slowly. P. How am I going to get P? To get P, I must resolve 10. Resolving 10 means you either move it down or up. So my question is, you must be knowing that to get P and Q, there are things which do not change. What are those things that don't change? The 10 must be there because it is the 10 we are moving. And we are using the same angle. So even the angle will not change. 45, don't forget the degrees. 45, don't forget the what? The degrees. So, of P and Q, which one is going to take the course? Which one is going to take the course? Is it the P or the Q? Let me go in the chat. Is it the P or the Q? 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 Yeah, you got the point. That is enough. But don't send more than one P's when you are the same person. So P is taking the course. Why is P taking the course? Because the 10 has to come and compress our angle 45. It has to compress it. Hence we shall have cos. But you people, when we compress the 10, or you look where the P is facing. Where the P is facing, is it a negative or a positive? Look at where P is facing. Is it a negative or a positive? Look at where P is facing. Positive, negative. The things we talked about in the beginning. Negative. Thank you. You've understood. So that means after realizing that for you to move towards the P, you have to compress the angle. Hence, we have cos. Hence, this one will take on sine. You appreciate that the P is facing on the left-hand side. So it has to be having negative. Hey, it must have a negative as you are resolving. We are going to see how this works. Then the Q is looking up. So for it to be a positive, you stop there. You get the answers from the calculator. Get the answer from calculator. Get the answer. Get the answer from the calculator. Hey, that one has been ours together. Now, this one is yours. This one is very technical. I think you people, you are aware that for if you want me to give you money, you first raise up your hand. I put the question. When you pass it, I give you money. So he is putting up the hand first. Rita. Rita has been the first. Rita, unmute. Rita was the first. Rita, unmute. Are you ready?
Yes,
Rita, are you ready?
I'm ready.
Yes. Okay, Rita, this is our particle, Rita. And someone is pulling our particle at that angle. And this person is using a force of 5 newtons. 5 newtons. What is the angle? We have this component. Are you listening?
Yes,
We also have this what? This component. Now this component, I'm going to call it U. Then I call this component V. Then the angle at which the person is pulling. I don't know whether this one is vertical enough. Let me make it more vertical. This is vertical. So we have said this one is our U. And the angle is 30 degrees. So Rita, I want you to tell me what is U and what is V. You people remember I say don't forget the right angled triangle. So our first diagram is wrong. Why? It doesn't have the right angled triangle, but now it's correct. Even here, the right angle should appear. And no one should ever lie you that Simanya, that force should pass through this corner. Like if this is the angle, Simanya, the line has to pass through this corner. No one should lie you. You can have your right angle like that, then the force comes like that. Because when it is there, you as if you're meaning the angle is 45, which is not right. You can only put it in the middle if it is 45. Then for you are so accurate. And a mathematician that is known from Owino or from Chinatown. So Rita, you are the one delaying progress. What should we do?
So U is equal to -5 cos 30. I'm not seeing anything. Teacher,
people, sorry. Network had jammed. Rita, what had you said? Thanks for being patient. Those who have stayed. Rita. Where is Rita? I can't find Rita. Oh, she's here. Unmute Rita.
Yeah, teacher, I was saying.
That
Okay,
you're not seeing.
I'm not seeing anything.
Are you sure?
Okay, now I'm seeing. I was saying U is equal to negative.
Negative. That is nice. Negative what?
Negative 5 cos 30 degrees.
Cos.
And V is equal to cos.
Have
Yes,
you
cos.
said cos? Then?
Cos. And V is equal to negative 5 sine 30 degrees. Yeah.
Exactly. Thank you very much. So that is it. Eh? So as usual, the things that are obvious, the 5 has to be there. The 5 has to be there. Even our angle 30 has to be there. Now realize to get U, we shall have to compress the 30 using the 5. Eh? The 5 should come and compress the 30 for us to get the U. So we are compressing. So we have to have cos. So the other one will take sine automatically. Why? We are moving away. Now you look at V. V is facing the left-hand side. So it is a negative. U is looking down, still negative. You understand? So these are important notes to take. Negative. Rita, are you still on?
Yes.
Hey, do you have an MTN number?
Yeah, yes.
You read it now, very fast.
07.
07. For me, I have a machine that sends money. 07 what?
7. 63.
63.
84.
84.
963.
963. For me, I have a machine that sends money. You just tell me the number. Enter reason, serious student. Florence.
Yes.
Okay. Keep quiet. Don't tell people the amount. Because when you tell them that I've sent you 50K, they may not accept. Have you seen the message?
Yes.
Have you seen the message?
Yes.
So don't tell your friends that if whoever is serious, I give out 50K. That should be our secret.
Yes.
Okay, Rita, thank you. Okay. I think now people have the point. If you can literally do this, who is ready? Now, this one is obvious. Let me then first put a certain heading. More complex cases. More. So today we are going to just introduce forces since people had issues. Then it will be the next lesson where we shall do that item. Are you seeing that item? It was supposed to be done today, but people didn't have the theory. It is a very good item. I'm going to share it so that those who can even try it after here. Okay, people can do it after here. Yeah. You're going to do it after here. So let's look at more complex cases. Please don't get tired. Don't give up. It is endurance that God blesses. When God sees that you're tired, you're seeing your data going too much, but you decide to stay and study to look for that A in math. That's what God blesses. So more complex cases, I don't think this one anyone can say me. But let me look for Emmanuel. Emmanuel, unmute.
Yes.
You are ready?
Yes, sir. Very ready.
Very ready.
Yeah.
Okay, sir. Emmanuel. Emma.
Yeah.
You are going to see real math. Emma, here I'm going to ask you to give components, not to swallow or D. I'm told there are competitions that side.
Which is
I was
okay.
there last week. Is it true that there are competitions of OD? You
Where?
just swallow. They
Where?
were like,
I don't know.
okay. Diba, Emmanuel Diba. You
Yes,
tell
please.
us, what is A, what is B? These are more complex cases. There are people who have been in the comment section giving us correct answers unconditionally, non-stop. You do it again.
You want A?
The moment you start search, you are defeated. Now you think I want it too. Yes,
No.
you want A.
It's going to be 3 cos 60. So it's -3 cos 60 degrees.
Yes. Do you have an MTN number?
It's off.
You see, now you have missed. Yes.
I can have number.
But you have not yet passed part B.
Part B.
So this one, okay, first tell me B. What is B? Then I explain to people.
Part B, I can have it as either -90.
Either. Okay.
Yes, and they all give me the same answer.
Okay, Dibaha.
First, I can have it as negative 90 cos, it's going to be 3.
In Nigerian, they said they play.
That's oh. Going to be -3 -3 cos 150.
-3 cos what?
150 degrees.
Cos 150. People now forging life.
Not forging. I've taken
I'm reading messages in the chat, but I'm
Yes.
seeing people forging. Okay, Diba, you first stay on, but you stay quiet. We first reason this together. So people, because of angles on a straight line add up to 180. So this is 60 degrees. We all admit that this angle is 60. So since it is 60, A is obvious. A is obvious. Why? We shall, when A is facing a negative side, the left, so it is -3. And you can see, for us to get the A, we have to compress the 60. So we are going to have cos 60 degrees for the A. And that is correct. Use the calculator and proceed. But now B. B is a bit technical. We shall need to redraw. Yes, we shall need to redraw. Let us redraw and see what is true. Now, you people, I want you to look at this card diagram. It has this and this. It has this. Lux has this 3 newtons. Has this angle, which is 60. I want us to put another vertical line here. And be like, this is our angle, what? 90, isn't it? Then this angle, Diba. Which angle is there in blue? Diba, which angle is there in blue? I think Diba is off.
No, I'm on.
Which angle is that blue?
Where?
Here, in blue, here.
That angle is going to be 30.
30, thank you so much. Then this one is obvious, it is 90. Now, you people, do you agree with me? And I want you to agree by force. This force is the same as B, but it is positive. Is that true, Diba?
Yes, sir.
Do you see that? That this angle is also B because B is facing down,
And
but
up.
it can also face up. But when it faces up, the size doesn't change. What changes is the direction. It moves from a negative and now becomes a what? A positive. You understand?
Yeah.
Yeah. So, can you now say something about that B again?
Okay.
Because this B that you have is now a B, which is a positive. You first tell me what this B is. This one. It will be the one we have that is a positive.
Yes. It will be
It
3.
is 3.
It will be 3 cos 30
Cos.
degrees. 30 degrees.
You understand?
Yeah.
Now, this one down, that is a negative. It will also remain B, but with a negative just. I don't know whether you get me. Yeah. That will be better. So why am I doing all this? I want you people to appreciate and I want to let you know. Resolving is done best with acute angles. That's the note I wanted to derive for you. Note that derive resolution is best with acute angles. Resolution is best with acute angles. Do you know acute angles, Diba?
Yes, sir.
What are those?
Angles less than 90.
So even negative 50 degrees is an acute angle.
Pardon?
So even negative 50 is an acute angle.
Okay, they are less than 90, but not less than 0. They are between 0 and 90 degrees.
Exactly. So that is it. So, lastly, so Diba, the money
Yes,
is
sir.
gone.
Pardon?
The money is gone. Maybe we can do this last one. You can also give it a try. So the last
Give me,
one, also in class.
give me another one.
As people in the chat also be ready to say something. So I have this. I have something here. Then I have my course. I have my force here. And this force of mine is actually 4 newtons. Then I have my angle here. And that angle of mine is 300 and what? 15. Then here I'm going to put C. Then here put D. So members, let us start. C and D. C and D. E. Then I want us to make a conclusion after that.
Okay. I start with D.
Start with D. D is?
D is going to be,
it's
going to be 4 cos 45 degrees.
Yes. So you people, what we have here, the balance. The balance here is 40 what?
45.
Don't so? And for us to get D, we shall move that way. We are compressing the 45, not so?
Yes.
So D will be 4, and D is facing the positive, isn't it? So we have no problem with it. Cos 45. Yes, and that is correct. Now, my interest is C. I want to see members in the chat if they're going to pass. So people get... Hey, I
continue. I continue.
Yes.
So it's got to be 4 negative 4. It's going to be negative 4 cos 45 degrees.
You have failed by saying negative. You realize? Remember, C is facing up, so it cannot be a what? A negative. You understand?
Pardon?
Remember, C is facing up. So when it is facing up, it cannot be a negative. You know, when I do this,
it's facing up, eh?
When I do this, the angle here is also 45, not so?
Yes.
But this C I'm creating is not the target C. This C is a negative. And the C that you want is a what? A positive. You get? Yeah. So that means the C will also remain the same. Let me see if people said something in the chat. So you people, you wish me quick recovery. So 4, C is 4 cos 45. Yes. So you people who have negatives, never allow that. This C you are introducing, yeah? This you are introducing, yes, it is a negative, we agree. It is a negative, everyone can see that. But the problem, that's not what they want. Otherwise, if for you, your thing was C equal to 4 sine 45, like that, you are also right. Why? For you are using this first 45, which will give you sine. Then for us, we had used this 45, which is for cos. So don't lose hope. My worry is you putting a negative. So all those who have sine, you are right. But the only mistake you're doing, you are maintaining this C which is looking down, it is a negative. Yet the question wants a C that is looking up, which is a positive. These are things we began with. So hope you get the point.
So excuse me.
Yes.
So I have a question. So whenever you're having such situations,
yes,
and you try, let me say, maybe it's a positive or negative. So whatever you introduce in to help you find, you don't actually depend on it, like it's sign whether it's a negative or positive. You depend on the
yes,
other one,
yes. For you depend on the sign of what they want.
what you are actually looking for.
Yes, the magnitude is the same. You understand?
Okay.
The magnitude is the same. What it differs is the direction. So for you just to focus on the direction, and this can even be your side work. This can just be your side work. Remember, a first diagram is awarded once. If you have drawn that of D and it is very correct, no need of drawing another first diagram. You can do your side work, some other side, for you come and paste the right expression, and they will not even disturb you at all. You get the point?
Yeah.
You won't be disturbed at all. Hey. So the last one, I want the last one to be passed by all people. Yes, the last one. Get ready. I'm still confused on how we know that it is cos or sine. Oh, right now it is a long story. But cos is when the angle is getting compressed. Then sine the opposite. So lastly, don't complicate these things, people. Just make sure you're using an acute angle. It is better. Using these other angles, it may disturb you a bit, but it also works. It also works. But I want you to be good students of mechanics. Students who prioritize the real angles. Yeah? But I can shock you. But I don't want you to learn such methods. They are a bit weird. They're a bit weird. But it can actually work out. Maybe I will teach you with the time.
I think I've understood this.
Hmm?
Yeah. Now I've just understood the technical part of it.
For you concentrate on the direction they actually want, but these are more complex cases. Remember that the other cases that are easy. Those ones are very easy. Those ones will not get disturbed, but these complex ones, that's why we had the heading more complex cases. Hey, they are very rare to be set. But as you know, we want to create students who are competent, not students of cram work. Hey, but other things can also work very well, very well. And why we prefer that thing of acute angles? You look at this example. Are you seeing this example? Do you see that someone will be confused? Why? Someone will be seeing A, but for A, we compress the angle. Even for B, we compress. You see that confusion? But if someone comes up with acute angles, it is always better. However, even those ones work, but it wouldn't be something
Like they want to use that first.
see.
Like they want to use that first because it was also giving the answer.
They are okay, but I want you to befriend the acute
Acute.
angle. So lastly, this one I will not judge anyone. Whichever you use, it is okay. So this is going to be our 20 newtons. You're listening?
Yeah.
Have this. This one is 240. These are more complex cases. Now, I want members to give me I want you to see that now things are getting easier and easier. So this one is going to be our W, and this will be our V. So you tell me W, tell me the V. Begin with whichever you want.
This one is going to be, this is more simpler now.
It is simple because the other ones have been coming in.
So W is going to be 20, negative 20 cos of 60 degrees.
Cos of what?
60 degrees.
Because from here up to here, it is 180, isn't it?
Yes.
So that means this balance is a 60, isn't it?
Yes.
Or someone can say, from this point, if it is our point 1, up to point V, those are 270 degrees, isn't it?
Yes.
Like that first point is 0 degrees, and this is 270. That means this one is 30. Also, and if this one is 30, that means the other one is what? 60. So either way you can reach. So that you've said W is negative 20. That negative is very important. So do you realize you're saying W is negative because it is facing the left? You are not even concentrating on other things. Then you come and resolve in peace. And since you're compressing a 60, it is a 60 you are compressing. So what do you say? Negative 20.
Cos 60 degrees.
Cos 60 degrees. Don't forget the degrees. Yes, that is correct. Then V.
Then V will be also negative 20 cos 30 degrees.
Then V is what?
V is also negative 20 cos 30 degrees.
Cos what?
30 degrees.
Because you are compressing the 30, not so?
Yes.
But do you see that also for V, I'm moving away from a 60?
Yeah, it can also be a negative 20 of sine 60 degrees.
Where sine 60 degrees. Good. Then I also think that for a W, we either compress a 60 or move away from a 30. Do you see that?
Yes.
It can also be negative what? 20 sine what?
30 degrees.
So that is. Hey, at least people get this kawan. Hey, now when you get this, when you go to the other ones, everything becomes easy. So are you saying that you've not even used the 240 anywhere?
Yeah.
The 240 would disturb you and you will not be a strong mechanics student. You have to be that student who is using acute angles as you're resolving. Everything becomes easy if angles are acute. But when they become large, my dear, you get disturbed. So just play around with your circle, you balance those angles and see how can you deal with something of the sort. You get?
Okay.
Now, lastly, yeah, people are even reminding me that your account has to be credited. Do you have the MTN number as I put the last one? So this last one, you have now successfully gotten everything.
Yeah.
So you have the MTN number?
I have.
Okay, let me first do the diagram, you read it. As people do this one. So people, you pass this, eh? You pass this and I will be very happy. You are joking. So I want to see if people can give me the total Roman 1, capital F, X, and part B, the total capital Fy. Capital Fx, you know it is the horizontal. It can either be this side or this side. Even the y can either look down or up. But this time round, I need the total. And by total, I mean you add. So you add all of them. that can give us something in the horizontal. Then you do what? You also add all those that can give me things in the vertical. And this is where we are beginning from, yeah? So this is what I call in-class research. It is what is supposed to be taught next, but I want people to do it now. I see in-class research. It was supposed to be research, but I want people to do it today. In-class research. In-class research. Yes. We are going to just have a table of all those that will fall in the horizontal, all those that will fall in the vertical. Yes, then later we shall have a total. So members, prepare those forces. Eh? So this will be our total. Yes. And that total will be your own assignment. Yes, the goal today was people to learn what a force is, how they resolve. Then the resultant is yours. Then next time we shall combine both. Now, for me to handle this, as I'm sending Emmanuel money, I want someone who is going to raise up their hand as people are trying to organize their texts in the chat. Someone who is going to raise up their hand. You tell us all those that are falling under the horizontal. Then another one, you tell us all those falling under the vertical. That's what I want to listen to. So, let me turn on my machine. You just read your number. Just read it.
0766
0766
09
09
91
91
15.
15.
Yes.
Reason serious student. John.
Diva, yeah.
So now girls are going to inbox you, but don't reply them because they know now you have some 50K. They're going
Don't
to
worry.
add you, but don't reply their messages. Have you seen the message? Don't tell people
Yes.
that I sent you. That should be our secret. You should not even tell them the amount. They will feel bad. Hey, don't tell people that I've sent you 50K. Tomorrow, you go and withdraw. Have you heard?
Yes, sir.
Hey.
Thank
Okay,
you, sir.
Emmanuel, thanks for being active. Okay, who is ready? Daniela. Where is Precious? Precious was complaining that I wasn't picking her. Now she's pissed. She doesn't want to talk. Is this an overnight? No. We are concluding. That is a research question. That means whatever was supposed to be taught today is done. We are just trying to conclude. Yeah? Let me pick Daniela. Yes, Daniela, unmute.
Okay, teacher, doctor, me
Yes,
I'm going to show the components in the X.
X.
In the X.
Start with the 2. What does 2 give us in X?
2 cos 45.
Yes, please.
2 cos 45.
Is it positive?
Yeah, it's a positive.
Thank you so much. Correct. So 2 cos 45, it is a positive. What does 3 give us?
Negative 3 cos 20.
20. Why? Here there is a balance of 20, not so?
Yes.
and it is looking the other side, so it will be -3, and we are compressing a 20, so it will be cos. This will be 20. Another one, the 4. What does the 4 give us?
-4.
-4
Sine
is looking the other side. Sine what?
Sine 85.
But wait, this angle is not right. This angle is not right. Let us put another angle. Sorry, this angle is not right.
Yes.
This angle is supposed to be 105. Yes, supposed to be 105. Which angle is here? Tell us which angle is here.
The angle
This
there is 75.
75. You see those big angles, they disturb, but 75 cannot disturb you. Do you see that?
Yes.
So what does it become? -4?
-4 cos 75.
Cos, because you are compressing the cos, so things become easy. Thank you so much. All of them are correct. Who is going to give us those in the Y? Yes, Edith. Unmute. Edith, unmute. In the Y, start with 3. Okay, start with 2.
You have 2 sine 45. 2 sine 45.
2 sine 45, correct?
And then
Then
3 sine 20.
3 sine 20.
4 sine 75.
What have you said?
4 sine 75.
Negative, positive?
Negative.
Negative. When did you learn this? Today?
Yes.
Yes, thank you for being a serious student. That's really a success. Learning resolution in the first lesson, that is a success. I'm seeing it for the first time in my entire life. Those who are writing on my screen, I'm noting. So now I said, Jennifer, you press the calculator and add for us all those values. Now I say you add those of FY. Let me also contribute and I add those of X. You people know. The last one is sine, isn't it? It is sine. Because we are moving away from 75. Yeah. Yes. So let me add. Namwase Jennifer. Unmute and tell us what you get on FY when you add. For me, I'm adding FX. 2 cos 45 minus 3 cos 20 minus 4 cos 75. Yes, I'm getting negative 2.44014. These are newtons. Namwase, what are you getting?
Teacher, I'm getting -1.42343. Yes.
You are going to repeat for me. What do you get?
Yeah. -1.4 2 3 4 3.
Mine is giving me positive. Why?
I don't know. Teacher is brackets.
Mine is giving me a positive. Why? Is there anyone else getting a positive, or it's my calculator having issues? It's
Teacher, try
negative.
using brackets.
I try what?
Using brackets.
Oh, yeah, I've seen. Had not put 75, I'd put 7. 2, 3, 4, 2. Is it like this in newtons?
Yes.
What would you
Yeah.
like to know about Newton?
So that is it, eh?
Teacher, it's
That is it.
3.
What do you mean?
The last digit is 3, like rounding off.
Okay. I think I'm tired. Yes. So now, lastly, Dr. Given is logging on. He wants to advise you. So let's write this note. Yeah? So shall begin from there next time. I don't want to overstrain you. Eh? So I'll say next time we begin with the research question. Yes. That research question, it has been in class research. Eh? That one. If you really get it, just know you're blessed. Next time. Next time we shall begin. Next time we shall begin with the research question. But truth be told, today I've taught too much than what I actually had to teach. But you know, it is favoring us. We need to be stress-free in second term. We shall begin with the research question next time. And I wish you happy premium classes. Happy premium classes. It has been our last lesson. But it being our last lesson, it won't stop me from giving you the assignment. Yes. It won't stop me from giving you the assignment. Assignment is easy. Put here. Five newtons. And I put here 30 degrees. Let me see if doctors come. Yes, doctors come. So doctor, you can be talking to them as I write the assignment. We are done.
Yes, Dr. Lutaya. Thank you for the work done. I don't know what we can tell these kids. I think we have taught them a lot. Since Saturday, we have been teaching you senior fives for free. There are even some kids, doctor, I bought for data. There's some kids I even bought for data, so they could be motivated to start to study. So children, me, as I told you, we had an afternoon session where I was teaching. We had an afternoon where I was teaching, and most of you are telling me we are in chemistry. Me, I don't know which chemistry classes or math classes you are talking about which don't have Dr. Lutaya in them. In fact, I was in a senior 6 lesson. I even took off to come here and I make sure that everything flows perfect. I left the senior 6s with some work to be copying so that I could spare some time and be here a bit. So, members, when they talk about chemistry and math lessons, there's only one person. That is Dr. Lutaya. Those who are subscribing to me for biology, make sure your chemistry teacher is Dr. Lutaya. Or else I will be having a biology lesson when you are having a chemistry lesson with what? Senior 6 says, I'm sorry, I'm requesting for some 5 minutes. Senior 6 says, I'm requesting for some 5 minutes. Sorry about that, I was in senior 6. So I was saying, if you choose any other teacher, the problem is on you. Me, I will not listen to things of Mr. Given, don't teach, I'm in a lesson. There's only one teacher I know teaches math and chemistry, that is Dr. Lutaya. Children, we told you that when we are making our timetables, I sit down with Dr. Lutaya and we make the timetable so that it does not collide. Whenever I'm teaching biology, you will never find I was saying, whenever I'm teaching biology, you will never find a math lesson. Whenever I'm teaching biology, you will never find a chemistry lesson. Whenever it is math like now, if it is math like now, we are very sure, we all know it is math, you will never find a biology lesson. But when
Okay, now members, hope you got the communication clearly. Yeah, we just don't want you to be colliding. That's one problem. That's what we don't want. We just don't want you to collide with lessons. But if lessons are being recorded, of course you'll be in position to catch up. Now, this is our last question. So in the chat, meanwhile, please anyway, I'll talk about that. Now, I want you to comment. How have you found your first lesson of mechanics? Yes, yesterday I told the mass spectrometer, you said it was okay. The other time we did logarithms, you said they were okay. But you said they are okay, you don't do assignments. Even the assignments I left for electronic configuration streams have not handed in. And I'm now also leaving this of I'm leaving what? I'm leaving this one of also of math 2. So how have you found resolution of forces? You comment. You comment. Your comments actually matter a lot. Yes. If you don't comment, you're a bad child. You don't comment, you are a bad child. Yeah, this one can be resolved. This one can be even this one, even the other one, even the other one, even this one. I think we should put an angle here. And say yes, and say 120. Yeah, 120. Then this one will be find the total. I don't know what's wrong with some people. Some people are possessed. You comment about writing on the screen, they just do it deliberately. So you're going to find the total, part A, fx, then part B, the fy. Yes, and that is the end. is the end. So remember, I'm sharing this workbook after you. So you don't need to worry if you don't actually have the notes copied. You're going to get it after. So unless someone has a concern, but yeah, that is it. This has been your last lesson. Hope to see you in the premium classes starting tomorrow morning. Yes, realized we are out of time and a lot has to be handled. So beginning May, we are already in May. It is even just midnight. So it is actually May, so the premium lessons begin today. That's what people are saying in the chat. Yes, thanks for the perseverance. Let me read the messages. I can't sleep. I told you that I'm sleeping today. Complex one are still be changing. Don't worry. Yeah, I sent the logarithm recording. The recording is going to be shared. Yes, go back and challenge your teachers. Yes, the PDFs, we are sharing them. Boring ending. Of course we are ending. So what do you expect? Review the questions, scroll. First diagram, scroll. Happy new month. Okay. Let me expose the questions for those who want to see them. So it is advisable you do this work in groups. Let me see this question we did for research. Okay. So those are very good questions. Very good ones. Total. That's where we shall begin from. I'm going to even share. By the way, you see, for questions, you go with the many as far as we can. Research. Find the magnitude. Find the magnitude of the resultant force. Of the resultant force in part A. This 3 newtons, 4 newtons. Part B, 8 newtons, 6 newtons. this part. Newtons, 1 Newton, 10 Newtons, this one is 1 Newton. Then I'll give you a hint. You know, research means that that's where we shall begin from. Yeah? You're working, you're working, you're working, your diagrams. I want to see if you can draw correct diagrams. Yes, so this is the real end. Yeah? Sorry that I've yeah. Unless someone has a concern. Let me tell you, what you're seeing, oh, no, it's not because they are enduring. Some of them are dozing. You like it or not, that is it. Most people are just dozing. So let me pinch for you the screen for just a minute. You copy and go.
Excuse me. Excuse me.